Greetings, viewers. This is Chubin Khurana, and welcome to my channel. Before starting AI presentation, just want to put the disclaimer that I am not the SME for AI/ML. So instead of a monologue, let's just have a dialogue during this presentation. AI, a historical perspective. The AI field was founded on the claim that human intelligence can be so precisely described that a machine can be made to simulate it. However, the concept of machines or objects with intelligence has been around since antiquity in countless myths. In science fiction, AI is considered a danger to humanity if it progresses unabated. Outside of science fiction, a concern is that AI, unlike previous technological revolutions, will create a risk of mass unemployment. Let's try to unwind some of the myths. Why is there a hype for AI? Because many experts agree that AI would create a huge amount of value. For example, according to a study by McKinsey Global Institute, AI would create an additional 13 to $22 trillion of value annually by year 2033. Of this, 13 to 22 to 3 to $4 trillion is predicted to come from what's called Gen AI, also known as generative AI, which is a relatively new type of AI technology and also niche that can produce high quality content, specific text, images, audio. That's why AI is the new oil. And McKinsey's study points out that a lot of value to be created in the future lies outside the software industry. For example, in sectors such as retail, travel, transportation, automotive, materials, manufacturing, and so on. You name any, AI will be there in one way or the other. A large a large amount of the value we see from AI today is ANI, also known as artificial narrow intelligence. These are the AIs that do one thing such as smart speaker or self-driving car or AI for the web search or AI applications in farming or in a factory. These types of AI are one trick ponies, but when you find the appropriate trick, this can be incredibly valuable. With the rise of generative AI, things like ChatGPT, we are also starting to see AI. This is a bit more general purpose. For example, ChatGPT can be a copy editor, brainstorming partner, text summarizer, and help with many other tons. These models have been an exciting development and further expanding what we can now do with AI. In addition, AI also refers to the concept of AGI, artificial general intelligence. This is the goal of building AI that could do any intellectual task that a human can, or maybe even artificial super intelligent and do even more things than any human can. Actually, here we talked about three things: ANI, AGI, and ASI. The father of AI is John McCarthy. He is a computer scientist who coined the term artificial intelligence in 1955. McCarthy is also credited with developing the first AI programming language, Lisp. The term artificial intelligence was coined by him. He is one of the founder of the artificial intelligence, together with Alan Turing, Marvin Minsky, Alan Newell, and Herbert A. Building blocks for AI. AI, field of computer science that seeks to create the intelligent machines that can replicate the human intelligence. Machine learning, It is a subset of AI that enables machines to learn from existing data and improve upon the data to make decisions or predictions. Deep learning. It is a machine learning technique in which layers of neural network are used to process and make decisions. LLMs. This might be new to you. It is a statistical language model, also known as large language model, trained on massive amount of data that can be used to generate and translate text and other content and perform other NLP tasks. You must be wondering what NLP is. NLP, also called natural language processing. LLMs are typically based on deep learning architectures such as the Transformer developed by Google in 2017 and can be trained on billions of text and other content. LLMs are big, very big. They can consider billions of parameters and have many possible uses. Here are some examples. OpenAI's ChatGPT 3 model has 175 billion parameters. Its cousin ChatGPT can identify patterns from the data and generate natural and readable output. While we know that the size of Claude 2, it can take up to 100,000 tokens in each prompt, which means it can work over hundreds of pages of technical documentation or even an entire book. AI 21 Labs Jurassic 1 model has 178 billion parameters and a token vocabulary of 250,000 words parts and similar conversational capabilities. Coil Command model has similar capabilities and can work in more than 100 different languages. Light on Paradigm offer foundation models with claimed capabilities that those exceed of GPT-3. This is a very unique claim. All these LLMs come with APIs that allow developers to create unique Gen AI applications. Applications of the LLMs are such as copywriting, knowledge base answering, text classification, code generation, text generation, AI assistant, sentiment analysis, and language translation. You all must be wondering what the future of LLM is. The future of LLM is audio-visual training, workplace transformation, and conversational AI. So we can see here a Tesla autopilot car video. Autopilot self-driving car is the example of AI, ML and DL. In this video it shows how application of AI works. I want you to just go through this video and observe what's actually happening. The person showing sitting in this car is just sitting for observation and nothing else. As this is a trial video, you can see the three cameras capturing things left, middle and right. So here we can see that the car is driving itself while the person is just sitting there. This is the future of cars. I would like you all to observe it very carefully. Below you can see some icons which are motion flow, lane lines, road flow, in path objects, road lights, objects, road signs. You can match it with the camera view and how the AI is interpreting it. So this was just a glimpse of the video, and I would like to continue with this. AI powered technologies have been around for a while, and some everyday examples are Siri and Alexa, customer service chatbots that pop up on websites. These are the three types of definitions we have come across AI till date by the College Dictionary, by Oxford Dictionary, and by John McCarthy himself. The John McCarthy said that the science and engineering of making intelligent machines. Types of AI: artificial narrow intelligence designed to perform specific tasks, machine intimate human behavior specialized in one area to solve the problem. It is available commercially as Siri, Alexa. ANI is also termed as weak AI. Next we have AGI, artificial general intelligence. It can behave in a human like across all tasks. Machine can learn continuously and as smart as a human. It is also termed as strong or broad AI. It aims to create systems that generally simulate human reasoning and generalize across a range of circumstances. These systems should be as capable as human in every aspect. They focus on less data as humans learn using minimal data. Next, we have ASI, artificial super intelligence. It is smarter than human stuff like sci fi. It is not available commercially. An intellect that is much smarter than the best human brains in practically every field, including scientific creativity, general wisdom, and social skills. Here, computers would be somewhat superior to humans, but they would continue to improve themselves. This is like science fiction, like sci-fi as of now, but transition from AGI to ASI is not a way. So the key takeaway is that there are three types of AI: ANI, AGI, and ASI. Now let's talk about machine learning. What is machine learning? It is a subfield of AI. ML gives the computer the ability to learn without explicitly programming. While in traditional programming, developers write with explicit instructions from data to make predictions or decisions. Formally, machine learning is said to learn from experience. E. Write some class of task T and performance measure P, where learner's performance P and the task T in the class as measured improves with experience E. Most common ML models are supervised data with label. It is a category of machine learning that uses labeled datasets to train algorithms to predict outcomes and recognize patterns. Unlike supervised learning algorithms are given labeled training to learn the relationship between the input and the output. Supervised machine learning algorithms make it easier for organization to create complex models that can make accurate predictions. As a result, they are widely used across various industries and fields, including healthcare, marketing, financial services, and more. Unsupervised learning, data without label. Unsupervised learning is a type of machine learning that learns from data without human supervision. Unsupervised machine learning models are given unlabeled data and allowed to discover patterns and insights without any explicit guidance or instruction. Reinforcement learning, state and action. RL is a major is a ML technique that trains software to make decisions to achieve the most optimal results. It mimics trial and error learning process that humans use to achieve their goals. Software actions that work towards your goal are reinforced, while actions that detract from the goal are ignored. RL algorithms use a reward and punishment paradigm as they process data. They learn from the feedback of each action and self discover for the best processing paths to achieve final outcomes. The algorithms are also capable of delayed gratification. The best overall strategy may require short term sacrifices, so the best approach they discover may include some punishments or backtracking along the way. RL is a powerful method to help AI systems achieve optimal outcomes in unseen environments. The most common used type of ML is a type of AI that learns A to B or input to output mappings, and this is called supervised learnings. Let's see some examples. If the input A is an email, the output B you want is this spam email spam or not? 0 out of 1. Then this is the copies of AI used to build a spam filter. Or if the input A is an audio clip and the AI's job is output the text transcript, then this is speech recognition. More examples: if you want to input English and have output a different language, Chinese, Spanish, French, something else, then this is machine translation. Or the most lucrative form of supervised learning of this type of machine is that learning may be online advertising, where all the large online ad platforms have a piece of AI that inputs some information about an ad and some information about you and tries to figure out will you click on this ad or not. Supervised learning also lies at the heart of generative AI systems like the ChatGPT and chatbots that generate text. These systems work by learning from huge amounts of text. You download them from the internet so that they that when they given a few word as the input, the models can predict the next word that comes after. These models are called LLMs, generating new text repeatedly, predicting that what the next word they should output. Unsupervised learning. Let's say you are a garment brand looking for measurements to make t-shirts. As data, you have the shoulder, waist and chest size for males. You have to make 5 different sizes: extra small, small, medium, large and extra large. You will use unsupervised learning to divide your data into 5 groups. The central points of those 5 groups will be the shoulder, waist and chest size of the different sizes. So you have just clustered the data into 5 groups. These are called k-means clustering. Here number of clusters were fixed. Another example are Another example, you are studying Facebook profiles of a student of class. Your task is to identify the groups in the class. As data, you have the number of times person A tags person B and vice versa. Let's start with a simple example. Let's assume the max number of A to B tagging across the class is n. Now let's person X and Y have tagged each other P times. N to P would be a measure of the distance. Now put two people in the same group. If the N to P distance is below threshold, you end up with the groups in the class. Now this is the concept of strongly connected components. Here the minimum distance between the two elements of the clusters is fixed. Reinforcement learning. So there's two types of reinforcement learning. Uh, so sorry, I was just confused. So the algorithm basics are that reinforcement learning is based on the Markov decision process, a mathematical modeling of decision making that uses discrete time steps. At every step, the agent takes a new action that results in a new environment state. Similarly, the current state is attributed to the sequence of previous actions. Through trial and error in moving through the environment, the agent builds a set of if then rules or policies. The rules help it decide which action to take next for the optimal cumulative reward. The agent must also choose between further environmental exploration to learn new action rewards or select known high rewards actions from a given state. This is called exploration exploitation trade off. The key concepts are reinforcement learning. There are few key concepts to familiarize yourself with. The agent is the ML algorithm or the autonomous system. The environment is the adaptive problem space with attributes such as variables, boundary values, rules, and valid actions. The action is a step that the RL agent takes to navigate the environment. The state is the environment at a given point in time. The reward is the positive, negative, or zero value. In other words, the reward or punishment for taking an action. The cumulative reward is sum of all rewards or the end value. Why now? AI was there from the last 50-60 years, but why it became so popular now? It is mainly dependent on two factors: the amount of data and the performance of processing, that is GPU, graphical processing unit. Here you can see the different type of data. Now the data for AI has grown and AI works best on the data. So now you see that the data for the LLMs has grown so much that AI is becoming very popular. Here there is a term written which is neural network: traditional AI, small neural network, medium neural network, and large neural network. You all must be confused what is a neural network. So the name and the structure inspired by the human brain, mimicking the way that biological neurons signal to one another. Also known as artificial neural networks, ANN are a subset of machine learning. You must be wondering, what is this? I told you about neural networks. So this is a type of artificial neural network. So the NNs or the neural networks consist of interconnected artificial neurons organized in different layers: an input layer, one or more hidden layers, and an output layer. Each node each node is an artificial neuron that connects to the next, and each has a weight and a threshold value. When one node's output is above and the threshold value, that node is activated and sends data to the network's next layer. If it's below the threshold, no data passes along. Training data teach neural networks and help improve their accuracy over time. Once the learning algorithms are fine tuned, they become powerful computer science and AI tools because they allow us very quickly classify and cluster data. Using neural networks, speech and image recognition tasks can happen in minutes instead of the hours they take when done manually. Google's search algorithm is well known example of NN. NN are at the heart of deep learning algorithms or DL algorithms. This is what we have studied about the connection between the NN and the DL. Every day you can also see a few examples of technologies using NN and DL: image recognition, object detection in smartphone cameras, autofocus, online language translation services. Next we have an autopilot car. So you can see here that it is capturing the signboards. It is capturing the signboards on both the sides, people on the road both sides, dividers, vehicles on both the sides, trees marking on the roads, distance between the cars, speed, time, road conditions, tire pressure, and so on. Thousands and thousands of parameters. Does it mean this is fit for all conditions, environments, roads, rules, regulations, safety, and security? Maybe yes, maybe no. Answer to this is on the next slide. The risks of AI. As today's AI models are so new, so it has number of risks. Of course, it will mature with time, but we have to keep in mind its risk for now. Fairness. Bias can affect results. For example, a loan approval model discriminates by gender due to bias in the data with which it was trained. Accuracy. Not sure how all the data is. I mean, when the model was trained and based upon the inputs fed. Transparency. User must trust a complex system. For example, an AI based financial tool makes investment recommendations. What are they based upon? Accountability. Who is liable for AI driven factors? For example, an innocent person is convinced of a crime based on evidence from facial recognition. Who is responsible? Privacy and security. Private data could be exposed. For example, a medical diagnostic bot is trained using sensitive patients' data. Thank you for being with me till now. Please like, share, and subscribe to my channel if you like this video. That's all for today.